Okay, so let's do a problem using this formula. The U.S. Department of Transportation recently reported that 81% of U.S. airline flights arrived on time. In a random sample of 12 U.S. airline flights, what is the probability exactly 10 arrived on time? So my N, how many did I have? 12. P, chances of arriving on time, 0.81. 1 minus P, therefore, is 1 minus 0.81, which is 0.19. And wants to know x equals 10. So what's the probability that x equals 10? That's equal to n, choose x, so 12, choose 10, times 0.81 to the 10th. So this becomes p to the x times 1 minus p, the 0.19. How many failures did we have? If 10 out of 12 were on time, that means 2 out of 12 were not. Notice these two numbers, the exponents, are always going to add up to this. These two are the same, and the two on the inside always add up to 1. So there's some ways to keep yourself in line. Now 12, choose 10. And put in your calculator. I believe it was 66. .81 to the 10th. It's really important that you round these late if you're going to round them. I'm going to let this be like, we'll go like 6 decimal places just to be safe. 0.121577 and 0.19 squared should be 0.0361. And of course you can type this whole thing into your calculator and we'll give you the most accurate answer. But if you're not going to do that, 66 times 0.121577 times 0.0361 is 0.2897 if you're rounding to 4 decimal places, or 28.97 chance. Now what happens if I put this 66 times 0.81 to the 10th times 0.19 squared? It's the same answer. So just to make sure, you can round, just be careful with rounding. I would always suggest not doing it if possible. Now that's a pretty straightforward question. It was an exactly. What happens though if it asks you what's the probability that at least 10 arrived on time? That means 10 could arrive at time, or 11, or 12. This is the probability that x is greater than or equal to 10. Now that means I have to do all of these and add them up. Now we already did probability of x being 10 from before, 0.2897. What about the probability of x being 11? I need to do 11 and 12. That's 12, choose 11, times 0.81 to the 11th, times 0.19 to the 1st. So this is a very similar equation to what we have up here, just we have one more success, so the 10s became 11s, and one less failure, so the 2 became 1. And we have to check 12. Now that means we have 0 failures. Anything to the 0 power here, you don't really need it. And 12, choose 12 is just 1. But let's get some of our decimals here. Should be 12. This one is 0.2245. And then the last one is 0.0798. So these are all the probabilities of x being 10, 11, or 12. If I want the probability of at least 10 arriving, I need to add them all together. So I need the probability that x equals 10, plus the probability that x equals 11, plus the probability that x equals 12. So 0.2897 plus 0.2245 plus 0.0798. Put that in your calculator. So 0.594. So a 59.4% chance that at least 10 flights arrive on time. Now, in a random sample of 12 U.S. airline flights, what is the probability that less than 10 arrived on time? So that could be 9, or 8, or 7, or 6, or 5, or 4, or 3, or 2, or 1, or 0. That's 10 things to calculate and add together. Or you can remember that chances, let's think of opposites. Less than 10 and greater than or equal to 10 are opposites. We already found out the chances of at least 10 arriving, so the chances of less than 10 arriving is the opposite of my answer to B, which means it's 1 minus 0.594, which is 0.406. If you can, you want to use this. If I didn't ask you this first part, and I asked you the second one, you would still want to calculate this first part and then do the subtraction. It would be much less work than doing this 10 times. So just be aware of that. So let's talk about this table, the binomial probability distribution table. One of these exists in your electronic textbook. We call it the binomial probability distribution. So what is this thing? This tells you your number of trials on the left and the number of successes and your overall probability based on what your chance of P is. So if we talk about like the coin flip, you would use P equals 0.5 because you have a 50% chance of getting ahead. If you wanted to have like a four-sided spinner where you had a 0.25 chance, you could do that, and this would tell you the probability of it getting exactly that number. Now for each number n over here, each probability adds up to 1. Okay, so let's just quickly look at number 3, then we'll carry over into the next video. A student takes an 8-question true-false exam, meaning there's 2 outcomes, true or false, 50-50. Find the probability of getting 5 or more questions correct if the student guesses on each one. So how would I look for this? Here we've got n equals 8. It says wants 5 or more, so that's 5 through 8. The chances of guessing right on a true-false is 0.5, so I need these 4 numbers. And this is 5 or more, so I have to add them all together. So 2188 plus 0.1094 plus 0.0313 plus 0.0039. So I just take those, put them in the calculator. To get, you have a 0.3634 chance of getting 5 or more right when you're guessing on just a true or false. And getting 5 out of 8 isn't that great. So 63%, 62.5 to be exact. So you want to be doing better. This is why you can't usually go into a test and guess and do well. And we will continue 6.2 in the next video.